prime of x. Good. Can anyone help with the derivative?
Will it be x prime or 1 times e to the negative x? Yeah.
Very good. Awesome.
Plus
yes.
x.
Yes.
Times e to the negative, yeah. That and then 1/8 times negative 1/8 times 2x.
Very good. So this will be negative x divided by 4. Very good. So you bring 2 down, simplify, and you get 1/4. So negative x over 4. Excellent. Good. What do we do next? Very good. Who was that? I'm sorry, I didn't get the chance to look.
That was Josh.
Thank you, Josh. Good. What do you think I'm going to do next? All these are just algebra, and I'm really expecting you to boom, 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 tell me quickly what I need to do, because this is just algebra.
You're gonna factor out the e minus x.
Very good. What is left? Awesome. Next.
It would be 1.
Yes.
X squared over 4.
Very good. Least common denominator, please. There is only one.
4.
Good. And the numerator?
4 minus x squared.
Very good. Of course, I'm going to factor out negative 1. I'm going to bring this to the denominator so it doesn't bother me up there. So it's x squared over 8. And what else you're going to tell me to do? Again, this is part of the first class.
X plus 2, x minus 2.
Very good. Thank you, Mickey. Good. So now f prime of x undefined, f prime of x 0. Which one? Both or none of the above?
Equals 0.
Good. That's not possible. E2, whatever, can never be 0. Good. And then?
Negative 2 and positive 2.
Perfect. Okay, negative 2 doesn't fit. So I'm not going to bother with it. So now I have to find the function value at these 3 points. So I plug in y equals x e in parentheses negative x squared divided by 8, close the parenthesis, and second in table, and I plug in negative 1, 2, and 4. For negative 1, I got 0.88, sorry, negative 0.88. For 4, and what happened to 2? Where did 2 go? Okay, for 2, I got 1.21. And for 4, I got 0.54. I'm checking my function, x e to negative x squared over 8. That's correct. And negative 1, that's correct. 2 is correct. 4 is correct. Okay. Good. So now I have to study the sign of the derivative so I can fill in the sign here. So which portion of the derivative I refuse to plug in? If there is one, I should always know it, that I don't have to waste my time with it.
Denominator?
Exactly. It's always positive. So don't waste your time to even look at it. Okay, so I'm going to plug in the numerator, -1 and then 4. Can anyone give us the sign of the numerator, hence the sign of the derivative, when you plug in -1 and when you plug in 4?
It's the first one's gonna be positive.
Thank you. And the other one?
Negative.
Very good. Perfect. So now the moment of truth. I need to make sure that the two rows work well together. What does the function do here?
Increase.
Is that correct?
Yes.
Perfect. What does the function do here? Is that
Increase.
correct?
Yes.
Do these numbers support that? Good. So now I'm not graphing the function, not at all. I'm just plotting, presenting the -0.88 up to 1.21 and down to 0.54. Just to identify what each point represents. What is this point?
Absolute. Minimum.
So and relative, right?
It cannot be relative at the endpoint of the interval. What is this point?
The absolute and local maximum.
Absolute and also local max. Good. What is this point?
Nothing.
Nothing. Very good. Any questions? Any questions? Okay, then. I think we got the idea with all these examples. So, do you have any questions for me? I know, let me look at my phone because, as I said, all my clocks are all different time. Okay, so 8:34. So I have 10 minutes left. I don't know if I should start. I wanted to start section 4.2, but I don't think in 10 minutes is a good idea. So I'd rather answer your questions. Any questions? Any questions?
How can we figure out, like,
Yes? I only heard the first part of the question. I'm sorry, maybe.
oh, sorry, because my mute came back on. How can you tell us when the function is defined? Like, I know we look at f prime, whether to see if it's undefined or if we got to set it equal to 0. And I saw a lot of times that you crossed it out undefined. How do we know?
By looking at this derivative, knowing the graph of the exponential function, that it never touches 0 and never touches 0 times 4, this is never undefined. This function is never undefined because the denominator is never 0. This is not undefined. I was explaining here it's always positive. This will never be 0. So that's why I crossed it out, because this denominator is never 0. So the function is never undefined.
Thank you.
Here, sine and cosine are always defined. That's why I had to cross it out. Here, it's never undefined because, again, the same situation. This is never 0. I was telling you here that this will not be ever 0. It's not real. This is a polynomial function. So this cannot be undefined. This is a polynomial function. This cannot be undefined because a polynomial function is always defined. Is that okay? Here it's never undefined because even if it is undefined, the function is undefined at that point. So even if the derivative is undefined at this point, the function itself is not defined at that point. So it's a waste of time to even think about it. So if the function is undefined at that point, its derivative will be undefined at that point. So that cannot be a local max, local min, because the point does not exist. Does that answer your question?
Yes, thank you for explaining.
Yes, thank you. Anything else? Other questions for me? Anything else?
Hey, homework. Hi, so today I realized that it's due next day, right?
Yes, I wanted you to finish up the web assign for today. I didn't want you to have both due today.
So I was trying to solve the problem with the particle that moves. And my question is, I thought I could solve it 3 different ways. Obviously, I got 3 different answers. One way that I don't kind of understand is that, so let's see. Obviously, I mean, the particle is moving and somehow a point is, we want to know how the distance.
Yeah, let me find the problem with the particle. You're talking about the homework that is due on Thursday, correct?
Yes.
Yeah, let me see if I can find a problem with the particle. You cannot get 3 different answers. That's not possible, right?
That's correct. It's just I thought that I could solve it 3 different ways, but that's, well, anyway, once you bring the problem, then I could talk about it. And I cannot figure out which is the right way.
So you understand that it's not possible. There is only one answer.
Correct.
I'm looking for one with a particle. I got one. Very good question. So let me change I made a mess with all my papers. Sorry, I'm gonna change back the camera so I can write. Okay. So here it is. We have a particle. A particle is moving along a hyperbola, xy equals 8. As it reaches the point 4, 2, the y-coordinate is decreasing at a rate of 3 centimeters per second, which means it says the y-coordinate. So this is dy over dt. How fast is the x-coordinate? Dx over dt. Changing at that instant. And let me remove this book. Okay, so basically,
right, so I think that's easy. I just simply take the derivative of, well, solving for y, and I'll get the, wait, you're giving me dt, I just gotta get dx. So, but this problem is not like that. As a matter of fact, I tried that approach. The one that I'm talking about.
First of all, you have y equals 8 divided by x, or y equals 8 times x to negative 1. So when you differentiate implicitly, you will have dy over dt equals negative 8 times x to negative 2 times dx over dt. So you solve for dx over dt. So you have dx over dt equals dy over dt divided by negative 8x to negative 2. And now you will be plugging in when x is 4, y is 2, and dy over dt is -3. So this is -3, and this is 4 to -2. So -3 divided by -8 times 4 to -2, and you get the answer. So I think what you are experiencing is you have to find this, right? So this is your w, this is your y, and this is your x, and you have the Pythagorean theorem, if that's what you're asking. And there is only one way to get that.
All right, so the first way that I try to do it is